Alright, let's look at this question. Penelope exercises every Tuesday and Friday. Tuesday she jogs for 15 minutes, cycles half an hour, swims 45 minutes. Friday she jogs and cycles for 1/3 hours each, but swims for an hour. And they want to represent this information all in terms of minutes in the 3x2 matrix E. So 3x2. 3x2 means 3 rows, 2 columns. Okay, if it's 2 columns, then you know what? Most likely we're going to have Tuesday and Friday here, right? And then the 3 rows can be what? Jogging, cycling, and swimming. So jogging, cycling, and swimming over here. All right, then let's look. So for Tuesday, she jogs for how long? 15 minutes. Okay, so and then for Tuesday, she cycles half an hour. How many minutes is that? 30 minutes. And on Tuesday, she swims for 45 minutes. So they want it in terms of minutes. So we're having minutes. It's fine. Fridays, she jogs. So on Friday, she jogs and cycles for 1/3 hours. So how much is 1/3 hours? So 1 hour has 60 minutes. So if you're on 1/3 hours, you just take 60 and you divide by 3, right? Which is 20 minutes. So it's 20 minutes. Each swims for an hour has 60 minutes. Done. So this is your matrix. Part B. During the 1-week school holidays, Penelope decides to increase her jogging duration by 20%. Okay. Maintain cycling duration and reduce her swimming duration, reduce it down to 60%. So they want you to use matrix multiplication. Matrix multiplication, find matrix H to show that the respective duration, exercise duration for Tuesday and Friday during the 1-week school holidays. And so basically, H is like, how much they're going to reduce it by. And so actually we can see that H is generally going to be the same dimension. It has to be. And then jogging is increased by 20%, right? For both of them. So if I'm just going to write it, it's going to be 15 times 1.2, right? 20 times 1.2. And then for cycling, she's going to maintain it. So no change for cycling. And this is H, mind you. This is your final matrix. They just want you to find 2 matrices so that when you multiply them, you get H, right? And then for swimming, reduce it to 60%. So it's going to be 45, and you just want 60% of it. 60% of it. Yeah. And so basically, is you want a matrix for which when you multiply it by your original matrix. So let's write original matrix here. So just hang in there with me. What we want to do is we take our original matrix and we want to find some matrix such that when we multiply it by the original matrix, what we get is this, where we increased our jogging by 20%, we maintained our cycling duration, and we reduced our swimming duration down to 60%. What matrix can this be? And so first we see this is a 3x2 matrix, right? So this definitely has to be a something by 3 matrix because these two must be the same, right? And we see that the end product must also be a 3x2 matrix. So this tells me that this must be a 3x3 matrix. So that 3x2, this will be a 3, and we can see it from here, 3x2 matrix. The middle 3's go away, right? The final product will be a 3x2 matrix. 3x3 matrix, what can it be? So let's see. We take row with column, right? And this requires some mastery of like matrix multiplication. You can see that to get this number here, right? First row, first column. I'm going to use first row, first column. I just need 15 times 1.2. That means it tells me that definitely here it has to be 1.2, right? So that I get 1.2 times 15, which is this what I want. And that's all I want. I don't even want the 30 or 45. So actually it means this must be 0 and 0. So 0 times 30 is 0 times 45, and 15 times 1.2. You add all of them together. And you see that works because for the first line, or should I say for this element here, you take the first row and the second column. So you get the first row and the second column. You also do not want these two numbers. You only want 1.2 multiplied by this 20, which is this. And that's what you get. And so you can see for here, when you take the second row and the first column, second row, first column, you just want a 30. So what you see is that you need a 1 here. Right? And there should be 0 and 0. So that what you get is 0 times 15, that goes away, plus 1 times 30, which is this, plus 0 times 45, because you don't want the 45. And same thing for second row, second column, which is 20. Second row, second column, 20. You also have second row, second column. So you have 0 times 20, which is, it goes away. 1 times 20, which is this one. And 0 times 60, so that goes away. So that's fine. And the final one is third row, first column, third row, first column. You only want the 45, and you want it to be multiplied by 0.6. That means this value here should be 0.6. And you do not want the first, the other values, so that you see 0 times 15 is 0, 0 times 30 is 0, and you only get 0.6 times 45, which is this. And same thing for this, which is third row, second column, third row, second column. 0 times 20, 0, 0 times 20, 0, 0.6 times 60. That's what you get here. So this is your matrix that you want. So using matrix multiplication, you need to find this matrix H. Of course, it's a lot easier to find the matrix H directly, but this is required in your working. So this, you can say this will be equal after you've done the matrix multiplication, which is, it's basically this, but you simplify it. And what you get is 18, 24, like this. Done. Part C. Given that A is this matrix 1, 1, 1, evaluate the matrix B equals to AH. So B equals to A, which is 1, 1, 1, multiplied by H, which is this. And we just multiply it accordingly. So this is a 1 by 3 matrix. This is a 3 by 2 matrix. So finally, it's gonna get we're gonna get a 1 by 2 matrix. So I'm just going to create more space over here. The first one, first element is basically first row, first column, first row, first column. So it's going to be 18 times 1 plus 30 times 1 plus 27 times 1. Right? And then the second element here is first row, second column, first row, second column. So it's 24. So it's all 1 actually. It's 24 plus 20 plus 36. 24 times 1 plus 20 times 1 plus 36 times 1. Okay, and then we simplify that. And we should get 75 and 80. A 1 by 2 matrix. And now we want to explain what the elements of B, which is this, what it represents. And so you can see over here, these are, remember this is Tuesday and this is Friday. And this is what? Jogging, cycling, swimming. So actually let's write that down again. This is my Tuesday, this is my Friday, this is my jogging, cycling and swimming. And what we did was we added these three numbers up. So it's jogging, cycling, swimming, add up everything on a Tuesday. So that's the total time that she spent exercising, right? Jogging and cycling and swimming on Tuesday. That's 75 minutes. And when you add these three numbers up over here, you're basically adding the total amount of time that she spent jogging, cycling and swimming all together. So let's just write that down. the elements represent the total time in minutes spent jogging, cycling, and swimming on Tuesday and Friday. But not all together. You're splitting them, right? Tuesday here and Friday here. So we put in the word respectively. And when is it? This is especially for the 1 week school holidays, during the 1 week school holidays. There you go. The next part, part D, Penelope's speeds for the respective exercises are as follows. You can see jogging, cycling, swimming. And they're all in meters per second, yeah? Just take note, per second. Right now, they want you to use matrix multiplication to show that the total distance Penelope covered in the exercise on when? Friday, during the 1 week school holidays. So actually, if you looked at the previous, for the 1 week school holidays, right? This was Tuesday and Friday, right? Jogging, cycling, swimming, and this was it. This was the matrix. And they want you to only look at Friday for this 1 week school holidays. So we're only looking at these three numbers. And they want you to find the total distance that she covered, right? When she jogged, cycled, swam. Cool. And first thing we need to do, we need to convert these to the speed per minute, because all these are in minutes, right? And so if it's 2 meters per second, we see that 1 minute, you have 60 seconds. And so, for example, we can see that jogging from 2 meters per second, it becomes 2 times 60 meters per minute, right? Which is 120 meters per minute. Make sense? 2 meters in 1 second, but in 1 minute you have 60 seconds, so you have 2 meters, you times 60 to get 120 meters per minute. So basically everything, all these numbers, you have to multiply by 60. So let's start here. This is just an example. We actually have to use matrix multiplication. So we have to say that you have to multiply by 60 and let the speeds be put in the matrix like this: jogging, cycling, swimming, right? And of course 60 is a scalar, you just multiply it directly. And what do we do next? We want to find the total distance, and so once you found the speeds per minute, you multiply it by some matrix, 24, 20, and 36. 24, 20, and 36. How do you know it's like this? Because since we had like Friday like this, and this is a 3 by 1 matrix, then this has to be another matrix that is by 3, right? And we want our final answer to be a 1 by 1 matrix, just one number, which is the total distance, which must be 11.808. So this should be a 1 by 3 matrix, which makes sense, right? And so so from here, let's actually simplify first. Let's multiply the 60 in. So we should get 120, 360, and 48. Yep. And so this is the speed per minute, right? In particular, for jogging, cycling, and swimming. This is for Friday: jogging, cycling, swimming. And this is what? These are all the speeds for meters per minute. Yep. And these are all the times. These are all the times in minutes. And so you can see over here what we will get is 120 times 24, right? So it's the speed multiplied by the time, which gives me distance. And then I add together 360 times 20, speed times time again, and then 48 times 36, speed times time again. And all this will give me 11808. And this is in meters. And so I can say 11808 meters equals to 11.808 km. Shown. Yep. So there we go. Just as a quick recap, we're going back to this again. Speed times time equals to the distance. And that's why we see, if you take this matrix multiplied by this matrix, it's 120 times 24, which is the speed here multiplied by the time here, plus the speed here multiplied by the time here, plus the speed here multiplied by the time here. You add all of them together, all the three distances together, and you get the total distance. And we're done.